continue with the discussion that we have where we have stopped in the last class, and I have also explained what are the effects of environment as such on the earth, what is the position as such, how this the natural resources are getting depleted. We have discussed this. There are three aspects which are of great importance. I mean, those which are of more important global issues, say the global issues, which as such draw a lot of public opinion about about environment. One of them is certainly that is you have known as is this say ozone hole. Two is the greenhouse gas and global warming, and the third one is the acid rain. So it's, if we just can explain this, we can think about explaining these terms. Let us begin with this ozone hole in the beginning, in the first place, right? Let us start this, just if we can think of, here we can discuss about this ozone hole. You can observe this. This is our Earth. This is from a satellite picture. It's a real satellite picture. I mean, the colors that you see is this obviously the artificial colors. But here again, this particular part, this blue part that you can see here, is essentially the ozone hole. You can see this. What happens here is mostly what is happening is particularly the CFCs that are generally related to ozone hole. The CFCs are getting produced due to various aspects of human activity, like as you can see, particularly the release of the refrigerants in the natural atmosphere, natural environment. Now what happens is these CFCs, they have one important characteristic is they are highly volatile. And so you can see this. Yes. We can observe this by here. Let me explain you a little bit on this. Okay, we can begin here. This digital, you can see like this. See this, if you just observe, say, if you just observe this, it's not writing. Okay, here you can see if it is something like this, what happens is essentially if you just see this is the North Pole side, this is the South Pole. The wind current from various areas, particularly because of a prevailing wind current in this area, starting from crossing the equator, essentially from the troposphere, I mean just above us on the surface of the earth, they generally get carried away towards the South Pole. What happens here is that this particularly all these CFCs, essentially all these CFCs, they have two important properties. One of them is they are extremely volatile. And secondly, they are non-reactive, essentially non-reactive under normal I mean atmospheric condition, I mean that we see observe in our earth system, I mean in the natural system that we observe. Now what happens is, this particularly this wind current, they generally travel from different sources, and finally in the south pole here they get a lift, just because they are very volatile, from troposphere to stratosphere. Okay, there are three atmospheric divisions, as I think you know, the troposphere, stratosphere and ionosphere. So each of these is, troposphere is about say from the surface of the earth to about 6 to 8 kilometers, 8 to 18 kilometers, 8 to 12, 8 to about 18 kilometers should be say this stratosphere, and then finally on top of that is the ionosphere. So this particularly, as they move, say here, when they reach the stratosphere, that is what is called stratospheric ozone layer. When they reach the stratosphere, they generally under photochemical reaction, they begin to displace ozone by breaking the ozone into oxygen and then another oxygen radical. As a result of that, the ozone which is supposed to absorb the radioactive, say mostly the alpha ray radiations from the infrared radiations from the sun, they would not be in a position to do so as actively as they used to do. That is why you can see here over the large areas, over time, that ozone has accumulated, particularly close to this is this towards the southern hemisphere. This has generally generated a particular hole. This hole is very close to the tips of South America. So what I was observed, in the initial years, when the ozone hole was established, the phenomena of ozone hole was actually observed at about 1960s and 1970s. What was observed that there is a large relative incidence of skin and cancer diseases in the South American regions, just because people the scientists could find that the infrared radiations in those areas are much more than usual. Fortunately for countries like India, we are not very much affected by the impact of this ozone hole. But if it begins to increase, suddenly we will be at risk as well. So the one important thing is to reduce the production of ozone, depleting chemicals like CFC, chlorofluorocarbons. These chlorofluorocarbons have been, there has been a worldwide effort to reduce the use of CFCs as refrigerants. We still use refrigerants, in various aspects, like as you can see, the most common them would be the moisturizers, the vaporizers that you generally observe. So when you are buying a particularly a very cheap or very ordinary moisturizer or a foam, say this foam for shaving and all this thing, you are most likely to emit a certain kind of CFCs, because the CFCs, because of them being very extremely volatile, so they, whenever they are released, they come out with a lot of force, and that is the reason why you find the sprays and the mists forming. Okay, now this is where this is the global worldwide effort, and as you can see, the result of that was the Montreal Protocol. The Montreal Protocol has identified that this ozone hole has to be stabilized, or it has to be reduced as much as possible. And this ozone hole, even today, it is it's observed that is generally shrinking. I mean, due to there are scientific evidence to suggest, and these pictures can be regularly, daily basis available. You see, if this is generally, if you just go to the website of National Oceanographic Administration of America, you can write it down, National Oceanographic Administration of America, NOAA website, they would daily give the shape of the ozone hole. The shape of the ozone hole. You know, this NOAA website is very famous website. You go into any search engine, just type NOAA USA, that would give you this, it would reach you to the site, and there you can see this, the ozone hole of today, as it is today or maybe yesterday, like this. So you can see where it is, this is where it's very important. So the effect is like this. In nutshell, the effect is that the CFC is getting produced in the earth, on the surface of the earth. These CFCs being extremely volatile and supported by wind current would finally travel towards the southern pole, towards the Antarctic, and from the Antarctic, from in the Antarctic, from troposphere, it would travel to the stratosphere, and in the stratosphere, as by photochemical reaction, that means under the impact of sunlight, these CFCs would break down into the chlorine, free chlorine, and other free chlorine, ionized chlorine. This ionized, activated, energized chlorine would then react with ozone and to break the ozone into substances like oxygen and some other free radicals. So as a result of this, so the ozone hole begins to be depleted. So you can see here, ozone hole is essentially distinctively, that this is due to a man-made activity. Ozone hole is distinctly created by man-made activity. Till about, if you just go about, say about 200 years or 100 years before this time, say about 1900, we will find that there is no such incidence of ozone hole being observed. But today it is a fact that we are having a ozone hole, and which is sometime decreasing, sometime increasing as well. There are some seasonal variations also. Something like, particularly as you can see, during the summer time the photochemical reactions should be more than that of during the winter, or during particular incidence, particular type of mixture in a particular type of compounds present in that stratosphere would also actually influence the decay of ozone in the ozone cover surrounding the earth. So this ozone cover actually helps in absorbing the infrared radiation. So in places where this ozone would be, the hole would be created, this ozone hole would allow the sunlight to enter the earth without having any resistance as such. So there will be higher incidence of, and as a result of that, the higher incidence of skin cancer. There will be higher incidence of skin cancer. There will be higher incidence of several skin related diseases, eye related diseases, wherever there is an exposure. Wherever there is an exposure, whatever is being exposed to that infrared radiation would be affected. So this is what is precisely the ozone hole. This is what is the ozone hole is so very important. Okay.
Ozone hole is also one of the cause of global warming.
No, ozone hole is not generally linked with global warming. We generally do not say global warming is, as you have said, maybe, but that way distinctly all effects can be related to the other, but we would not particularly specially attribute global warming with ozone hole. Ozone hole would, principal impact of ozone hole is to, the principal impact of ozone hole is to observe the incidence of infrared radiation in the Earth's surface. Okay. Now having gone from here, if you can just observe this.
The wind current is carrying CFC particles into southern hemisphere, sir.
Right.
So is northern hemisphere is safer in this regard?
Actually, is about the wind current. Is tremendous. We have an established wind current. We generally say, that is why you can see that, the particular, say, rainfall taking place at one time, as hot and windy condition at one time is basically a typical wind pattern. So the observation has, so far it has been observed that the North Pole is not so much affected. So you cannot say, in the tomorrow's world, when there will be a gradual disturbance in the temperature regime around the earth, there might be some wind current which might also lead the ozone to the North Pole. Okay, this cannot be as such as can be said as North Pole cannot be said safe, but at this present point of time there is not enough significant evidence to suggest that the North Pole is also affected, or the areas around North Pole are affected. Greenhouse gas and global warming. I mean, this is another aspect, which has to be understood. We can also observe this greenhouse. Now, remember one thing here. Say this particularly, as I was discussing in the last diagram here. Say this is from the different wind currents that finally take place and go into and finally would travel in the stratosphere to deplete the ozone. Now let us go into say another picture here. We would work on say this to discuss about this global warming. Why it is called greenhouse in the first place? See here, if you just observe this here, we have a certain cover, is always natural in the above the atmosphere. We have a natural cover of say this is the cover of say CH4 and CO2. Okay, this is naturally available. From time immemorial we have seen there are greenhouse gases which are being produced. Methane is being produced without human intervention for the time immemorial, right? Carbon dioxide is being produced without human intervention from time immemorial. Now the situation is this CH4 and CO2, when they are in the atmosphere, they are forming a layer which essentially reflects some of this, the sun's ray that is coming in, would also be reflected. Would be reflected here. This particularly, as you can see, there would be a change in the medium. A certain part of that would also be reflected back. A certain part would be going out into the out of the atmosphere. So this is out of the atmosphere in the planetary system. Now here also you can see these things taking place. Now what has happened? This is a natural phenomena that has been taking place for time immemorial. There is nothing new about it. Greenhouse gases are not recent. Greenhouse gases are not new. But what is important is that here what happens is certainly like we have built industries, we have built factories for our uses, and we have the fossil fuel burning has increased, as a result of which what has happened is that the incidence, the concentration of this CH4 and CO2 has increased. So we can find a thicker layer now. We can observe a thicker layer of CH4 and CO2 now, as a result of which the thermal radiation that is being reflected back is now much more. So as a result of which what is happening is this the heat that is being produced remaining within the atmospheric system. So what it is impacting is, it is essentially impacting, it is changing the temperature on the surface of the earth. See, why it is important? Why it is important is just to suggest this. You see here, there are if you just observe, say if we just consider this to be the poles, this to be the pole area. If we just consider this to be the pole, here there are many ice cappings, there are many ice cappings like in the North Pole which are known as permafrost. Permafrost. These permafrosts they remain frozen. They remain frozen for the whole year. I mean, say they may be frozen for last several hundred million years. Okay, they are frozen from the time we know. These areas, these are the frozen layers. So they are, essentially, as you can see, all this, the continents, connected like this. This is the, and all this, if you just say observe these continents together, this water, this particularly the water body, as soon as these cappings begin to change, as soon as there is at least in a small change of temperature, say in the atmosphere, even if there is a small change of temperature, say about change of 1 degree centigrade, change of 1 degree centigrade would lead to some of this ice to melt, as a result of which the water level, the ice would melt and the water would be released and the water level would begin to increase. This would have a risk of inundating several lowland areas. This is number one. And secondly, this is not a case which would take place hypothetically in the future. It is already happening. The thing is, it is already happening. There are some areas, particularly in Northern America, particularly those places where there is certain tribe called Inuits, particularly in the Greenland and Canadian regions. These Inuits, some of their provinces are being so much submerged now in water, now that they have to leave their households. They have to go away from their households and they are being termed as the environmental refugees. This is a new term that has been generated so as to observe the effect of global warming. This is only about a direct impact of global warming taking place. Is in fact in many cases, many attributes, that's something like the impacts of global warming. As you can see, this typical global warming effects is like this. Say the first is disturbance in the reproductive regime. This is very important. Reproductive regime. Say this, the total say reproduction system of the animals, the birds, all kind of species that we would call as biota, all the reproductive regimes are being changed. So their reproduction time is getting shortened. Their habitat types are changing. They used to be resided at one portion of the earth where they are finding they can no longer remain. They are particularly used to a particular kind of cold temperature which would actually energize their reproductive system, is not being capable to do so. They are not being able to do so in effective way. So this particularly disturbance in the reproductive regime, and you can see the flooding is another another aspect that we observe. Flooding is one aspect. Disruption of communities. Then wind pattern, change in the wind pattern, then seasonal fluctuations, increased seasonal fluctuations. The areas which were supposed to be cold at this point of time is no longer cold. This year itself it has been said that in the several parts of China, several parts of America, they are not as cold as they used to be in the last winter also. And though the short-term changes are possible in the atmospheric system. Remember, we have to understand a scientific basis on this. The reason is there are certain things which are locally like to change. Within the environment, or say 1 year it changes, another year it stabilizes, it remains stabilized for some time, then again 1 year it changes. It happens. It's nothing to do with global warming. It's not necessary that all places would be similarly cold every year. Remember this. But when you observe that these changes are consistent, that means earlier what we used to see, these changes were inconsistent. Today it has changed, tomorrow it has again come back to its original format that it used to have. But nowadays what we are finding is the changes are becoming permanent and the changes are becoming consistent. So that is the problem of worry. There was a great debate at one point of time, and it's still continuing. It's still continuing, as I was discussing about the environmental politics in the last class, that whether global warming actually increases the temperature of the earth or not. There is a tremendous debate on that. But today there is a greater convergence among the scientists also that yes, global warming does affect the temperature regime, the temperature regime, the regime of the atmospheric regime, weather regime. All these things are getting changed, and this is a fact that is actually taking place. Okay. Now, having said this, this is what is this. Now, as such, as you can see, this particularly the effect of this global warming. There are many sources of CH4, CO2 as well, but this CH2, CO2, increase in the CO2 is essentially increase in CO2 is essentially due to the excessive burning of fossil fuels. There is no denying the fact that this is particularly the fossil fuels are resulting into the global warming, into the heating of the different temperature regimes. Now, having said this, having coming to this area particularly, as you can observe, now this is where this is leading to global warming and the effects that as I have discussed. So there are, you must also, whenever you are understanding this phenomena as such, you must also try to understand that there are still lot of doubt in the minds of the scientists about what actually causes this environmental disruptions. There is still a difference between a different body of scientists as to whether to blame global warming, whether to blame greenhouse gases as a parameter for global warming, as a factor for global warming, is still questioned. But as I have said, at today's world there is a greater convergence. There is a greater convergence among scientists to suggest that global warming is actually taking place. So we cannot just claim by saying that global warming is not taking place. We cannot just blindly take our face out of this. We have to accept the blame, and it is taking place. Okay. There is another aspect which is generally you must have also found out at different times. This is about acid rain. Let me explain a little bit on acid rain, how it actually takes place. This is some of you might be knowing already, but let me give you a simple figure as to suggest why this acid rain is essentially taking place. You can see this, if you just make a diagram on this, you see this, this is where the emission is taking place. Say this is where the emissions is taking place. This is basically of power plants. Say in a power plant, mostly the power. Why power plants? I mean, all kind of power plants wherever they are. That is, in a cement plant or anywhere, wherever you can think of. So this essentially, as most of the coal, in many cases, most of the coal, or even otherwise, many fossil fuels essentially has sulfur. So there would be a greater production of CO2 and SO2 in the environment. This CO2 and SO2 is in a particularly CO2 and SO2 would be essentially carried by the wind current that would actually be flowing like this. There would be some kind of, if this CO2, if it is not essentially, if there are called a dry deposition. The dry deposition is whenever there is no water vapor, it is not coming in contact with water. This is particularly, this dry deposition would take place near the surface of the earth where there is already a heat source. So here you can see a heat source. So this particular area would be generally heated. So the carbon dioxide and sulfur dioxide would be either in a suspended condition, or in the suspended or dry deposited. We generally call it dry deposited. That means it would remain on the surface of the earth. This is called the dry deposition. Now as it moves further, I mean, as you can see, it is moving further in the atmosphere. It says CO2 and SO2, if you can just think of CO2 and finally H2O would lead to finally would H2CO3, SO2 plus H2O would finally H2SO3. This would finally come back as H2CO3 and H2SO4, and 2 finally wet during rain or during any kind of atmospheric changes which would lead to higher moisture content in the environment would finally make them to come back to the surface, where in some cases wherever there is an alkaline environment, wherever they will find an alkaline environment, this alkaline environment, if it is an alkaline environment, alkaline environment would give rise to a buffer. It would actually work as a buffer where this H2CO3 and H2SO4 would be somewhat neutralized. Otherwise, this H2CO3 and this H2SO4, this acidity, this would increase the acidity, increase soil acidity, would increase soil acidity. So it would lead to soil and water, will increase the soil and water acidity. This increase in the soil and water acidity, would affect say the water regime, agricultural soil, then human health, and also is human health and say loss of aesthetic value, then say a higher pH, I think not to be mentioned as such, and as we have said, higher pH would require separate kind of treatment. All this is basically what it is taking place. All this would impact is all this as it is changing would essentially reduce productivity. Natural resource natural resource productivity natural resource productivity will be hampered. Natural resource productivity will be hampered. This would lead to this natural resource productivity is likely to be hampered. Okay, so this is where the challenges are. These three kind of global environmental issues, I mean the causes of general global pollution or environmental degradation is essentially can be linked with various industries, and many problems can be directly or indirectly linked to these problems. Many other problems which are smaller problems, minor problems in nature, can be also included within the impacts of similar nature. So what we want to say here is, one very important thing is the research related to is this is natural resource productivity. Why natural resource productivity is important is, our life, the human life, our culture, our sustenance in the world, our usual habits, practices are all dependent on natural resource productivity. If fish production goes down, if the agricultural production goes down, if the if our the generation of adequate power for all goes down, the likely impact would be on our day-to-day lifestyle. And similarly, at the same time, most of this natural resource is essentially of non-renewable in nature. So there is a need for protection of these things, protection of these natural resources which are related to all these aspects of environmental degradations. Okay. Now this is to suggest what are the main issues that we have dealt with. Now I'll go start a new topic today. Now here it is. This start is definition of, I think I generally definition of environmental terms. Definition of environmental terms. Definition of environmental terms. There are few things that we will try to explain, we will try to observe. One is this, these are very important aspects, as you will have further understanding in the environmental science and engineering, understanding the basic definition has a tremendous importance, So this is natural change or environmental change. Natural change or environmental change. Environmental under environmental we will generally explain soil, air and water. Degradation, there is another important term that we will, degradation. We would also discuss another very important term which is generally discussed, is this pollution. Pollution, environmental pollution, you can write environmental pollution also. Here you can say environmental pollution. Environmental pollution. And there is the fourth is this environmental pollution. We would also talk about environmental quality. Environmental quality. Environmental quality. So you can see here all these terms are of importance. Why it is important, let me explain you some of this. So as I began the class, if you remember, when I started the class, I said, don't confuse tsunami with an environmental degradation. Okay, I said these are natural changes. So pertaining to that, you explain this natural change and the environmental change. The first is to understand the term natural. You just take down a line on this. What is natural? We'll explain natural. We'll explain natural as something. We'll explain natural as something or some entity which has evolved or will evolve without a discernible influence of any living being, for example that of humans, to alter just 1 minute. Can you start the sentence again? What I have written?
Will explain natural as something or some entity which has evolved or will evolve without a disturbance,
Without a discernible
influence of any living being. For example,
for example human, for its sustenance. You write for its sustenance. In simple terms, it would mean that the substance or the entity is not directly influenced by human activity. For example, volcanic eruptions, earthquakes, huge surge of seawater, are called natural, and the change they impart, will be called natural change. And the change they impart will be called natural change. So, if a volcanic eruption, you continue. So, if a volcanic eruption if a volcanic eruption fills the atmosphere, fills the immediate atmosphere, with burnt ashes, it will neither be called degradation nor pollution, but only a natural change, but only a natural change, but only a natural change. Environmental change is also sometimes used synonymously with natural change, synonymously with natural change, synonymously with natural change. Natural change. Environmental degradation. Environmental degradation. The word degradation in the natural environment refers to the impacts by human activities or other anthropogenic causes So degradation is basically human culture induced change, that has evolved due to human culture that we know of. Human culture that we know of. In the same context, soil degradation would mean the deleterious changes in the soil characteristics that are completely separate from the natural changes, Deleterious changes means harmful effects, harmful changes, like suppose say you have by pollution or by any human activity you have increased the concentration of cyanide in soil. is a basically a deleterious change. But the soil would undergo a natural change. Always, soil is not a fixed a typical entity which would remain as it is. Its own characteristics would also change over time. I mean, within a seasonally, yearly, basis, seasonal basis, it would also change. The soil would be sometime more with water, sometime less with water. These are natural changes. But when you are changing the characteristic of the change you are changing the characteristic by means of a human intervention, which will have a deleterious effect, that is to reduce the productivity of the soil. In such cases, we would call it as soil degradation. Remember, this distinction is extremely important, because sometimes we would see that we'd also see this, as a result of which this basically attacks the basic concept of our understanding, in the sense like this. Say we would say a garden as a environmental degradation, but we will call jungle a natural change. Okay, so to idealize this is not easy. I mean, in the sense, for most of the planners, the jungle is a particular entity which doesn't have a value, but it essentially has more value than a garden. So the gardener in our department, the person who keeps the garden would be angry if we say him that you are actually doing a certain kind of environmental degradation, because you are not allowing the natural changes to take place. In the same light, a much of our human culture can be blamed for what has happened to the natural environment. In the same light, we can say Taj Mahal is an environmental degradation. In the same light, we can say many other construction, many other effects that we have carried on as human as environmental degradation. That is what the distinction it makes. So it's a natural change and environmental degradation. So any kind of human activity essentially disturbs the natural activity, natural cycle. So whenever it is changing that, essentially discerningly changing, and it is changing in a manner where it cannot be recovered back again, would be called as degradation. It will be called as degradation. In the same light, you can understand about air and water also. Okay, the similar type of degradation we would allow. Anthropogenic causes. Anthropo means human. Anthropogenic, human related or human caused effects. This is basically the term I will use continuously. So I am just trying to acclimatize you to the terms, particularly the anthropogenic causes and things like that.
Pollution can be termed as anthropogenic.
We will come back to pollution in the next class, just for a 5 minutes break. Okay, we will again assemble after 5 minutes.